Like, subscribe, share, and comment. Today we're gonna solve the Higher National Diploma Exam 2022 session, General Physics, question 1B, which says two small birds having positive charges 3 Q and Q are fixed at the opposite end of a horizontal insulating rod extending from the origin to the point x equals to d, as shown in the figure Q1B. A third small charge bead is free to slide on the rod. Roman 1. At what position is the third bead in equilibrium? Wow, 3 marks. First thing first we have to do is to draw back our diagram. As you can see, I drew back my diagram. I have the 3 Q charge here. I have the Q charge the other way, and I have the third one in the middle. Okay, now let us assume the third charge to be Q, the one in the middle to be Q. Let us assume the charge on it to be Q. Okay, let us assume to be Q. Now the distance between the 3 Q charge and the Q charge is represented as d. Now I assume the distance between the 3 Q and the capital Q charge to be x, and the distance between the capital Q charge and the small q to be d minus x. Now we are asked at what position is the third bead in equilibrium. Now for us to calculate the position for it to be equilibrium, now for the Q charge, capital Q charge to be at equilibrium, the electric force between the 3 Q and the capital Q charge should be equal to the electric force between the capital Q charge and the small q charge. Yeah, because if those two forces are not at equilibrium, are not the same, it won't be at equilibrium. And we know that electric force is given by F equals to Ke, electrostatic constant, times Q1, the first charge magnitude, multiplied by Q2, the second charge magnitude, all over the distance separating them given by r square. And for the third charge, capital Q, to be at equilibrium between 3Q and small q, F of what? 3Q capital Q should be equal to F of what? Small q capital Q. Yeah. Now let us calculate F of 3Q. F of 3Q capital Q will simply be equal to Ke, magnitude of 3Q, magnitude of capital Q, divided by the distance separating them, x. F of small q, capital Q will be equal to Ke, magnitude of small q, magnitude of capital Q, divided by the distance separating them, which is what? D minus x, all that square. Oops, sorry, square here too. Now F of 3Q capital Q should be equal to F of small q capital Q, which says we have Ke, magnitude of 3Q, magnitude of capital Q, all over x squared, equal to Ke, magnitude of small q, magnitude of capital Q, all over d minus x, all that square. Next we have Ke, 3Q capital Q, all over x squared, equal to Ke, small q capital Q, all over d minus x, all that square. If we simplify, we have Ke cancel Ke, small q cancel small q, capital Q cancel capital Q, we are left with 1 over x squared. 3 over x squared equal to 1 all over d minus x, all that square. Next we have 3 into d minus x, all that square, equals to x squared. When we simplify furthermore, we have 3 into d squared minus 2xd plus x squared equals to x squared. Next we have 2x squared minus 6xd plus 3d squared equals to 0. Now as you can see, we have a quadratic equation in terms of x. Yeah, because x is the distance, the equilibrium distance we are looking for. So now we can solve for x here, knowing we know from the quadratic formula we can look for x by using the quadratic formula, which says x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Now what is our a? Our a here from our equation, our a is 2. We have 2. Our b, what is our b? Our b here is negative 6d. We have negative 6d. And our c from our equation is 3d squared. We have 3d squared. Now when you substitute everything, you have x equals to 6d plus or minus square root of 36d squared, 36d squared minus 24d squared all over 4. Now x be equals to d all over 2 into 3 plus or minus root 3. When you simplify this is what you get. So now x will be equal to d over 2 into 3 minus root 3. Why x can't be equal to d all over 2 into 3 plus root 3? Simply because x should be less than d. So x should be less than d. That is why x equals to d over 2 into 3 plus root 3. No, we can't take this answer. X should be less than 3. So that is why we have x should be equal to d over 2 into 3 minus root 3. This is our answer. Now the next, Roman 2 says, can it be in stable equilibrium? Yeah, capital Q can be a stable equilibrium if and only if it is what? Positive charge. If it is positively charged. Why? Because here, if you can notice, 3Q is positive charge. Small q here is positive charge, right? So if capital Q is negative charge, for example, now capital Q being negative charge, you know, positive, negative does what? Attraction. So it will be pulled toward the 3Q charge because it has more charge than the small q. So if capital Q goes to be negative, it will be pulled toward the 3Q because 3Q is greater than Q. So it will be pulled towards the 3Q charge. Now, and if capital Q is positive, which is good, which means that what? Positive does repulsion. Repulsion means it will be repelled by the 3Q charge and also be repelled by the Q charge, which makes him to be at equilibrium at the distance x, which is given by d all over 2 into 3 minus root 3. Thank you for listening. Please, if you are not yet subscribed, like, share, and comment. See you soon. Thank you. Bye-bye.